Hello and welcome students. We are starting with a new topic today, continuity. Sorry. This topic is a topic from the calculus part of your syllabus. So in the calculus part, the topics which go in sequence are: first you learn sets, then you learn relations, sets, relations, then you learn functions. After functions, you study limits of a function. Limit of a function you study. Then you study continuity. You study sets, relations, functions, limit of a function. Then you study continuity of a function. Then you study continuity of a function. So this part we are covering in, normally we cover this in 11th standard. And then in 12th standard, we start with differentiability. Like as you have continuity of a function, you will deal with differentiability, that is in 12th standard. Differentiability of function you will deal with. Then you will deal with differentiation in detail. Differentiation you will deal with. Differentiation of function, in which we will differentiate a lot of functions. Then after this we will have indefinite integration. We will have definite integration. See, I'm writing the syllabus of your calculus which you have to study in coming time. Then you will have definite integration. After that you will also have application of derivative. There is a topic you will learn which is application of derivative. Application of derivative you learn. You will learn application of integration. You will learn application of integration. That is application of definite integral. You will also have differential equation. And application of differential equation. So this is your 12th standard calculus syllabus. This is your 12th standard calculus syllabus from here till these all and these two. This is your 12th standard syllabus, and here we have 11th standard. So let's start with continuity. I have covered sets, relations, and function, as well as limit of a function. Today we are starting with continuity of a function. Very interesting topic, and those students who love to enjoy the mathematical concept, they will definitely like this. So let me begin. I'm going to teach you this topic in much detail, the way I normally do it, and you will definitely be able to understand all the concepts. So let's begin. So see here, students, when I say continuity, this is name of the topic. Continuity is the name of the topic. So normally what are we going to do in this topic? See, we are going to, when we say continuity, so what are we supposed to do in this topic? So here I write, we will examine the continuity. We will examine the continuity of a function. Now when I say function, you know function means some rule, okay, some rule. And when I say some rule, it has to be on some variable. So we will write that we will examine the continuity of a function f of x, continuity of a function f of x at x equals to some number a. So I don't want you to get worried about all this. I will, as I told you students, that I'm going to teach you in detail. So slowly and slowly you will understand everything. So what are we going to do here? We are going to examine the continuity of a function f of x at x equals to a. Now in this statement, there are certain things which you are following and certain things you may not be following. So I tell you what you are not following. You are not following that what is the meaning of continuity of a function. You are not following what is meaning of continuity of function f of x at x equals to a. You don't understand this as of now. Don't worry, because I tell you slowly and slowly these all. Right now, what you are understanding is f of x. You understand that what is a function of x. F of x you understand. What more you understand? You understand variable taking a value, variable taking up a value a. So you understand this part. So you understand what a function f of x is, and you understand what is the meaning of x equals to a. So to begin with, what I said we will examine the continuity of a function f of x at x equals to a. There are some more words which could be used in place of examine. I could have said we will test. We will test the continuity of function f of x at x equals to a. Or we could have also had examine, test, or we will check. Okay, check the continuity of f of x at x equals to a. So one thing I understand that continuity is a kind of property of a function which we have to examine. Okay. So I will tell you what is meaning of continuity. Okay. So for that, let me first draw coordinate axis. So here I draw coordinate axis. I draw y-axis and x-axis. I draw y-axis and x-axis, and then I have this is y-axis, this is x-axis. So somewhere, okay, this is 1, 2, 3, 4, 5. These are numbers on x-axis. This way it will go to positive infinity. Here I have origin. This is all negative numbers. Okay, and so this will go to negative. Now you know, students, that a function can be plotted on graph paper. Okay, a function can always be plotted. If I have a function, I can always have a plot of that function. Okay, so what I do here first is, as I have here x equals to a, for the sake of better understanding, I will take x equals to 3. So suppose here the point which we normally, as I have written here point, what point have I written? I have written the point x equals to a. So in place of x equals to a, let us have x equals to 3. Okay, so what does this statement now sound like? It will be, we will examine the continuity of a function f of x at x equals to 3. So what is the point of examination? The point of examination is x equals to 3. Got that? So here we have x equals to 3, the point where I have to examine the continuity of the function. So see, this is x equals to 3. This is x equals to 3, and I have to examine the continuity at this point. Okay, this is x equals to 3. On this line, we have everywhere x equals to 3. You see this? All these numbers are x equals to 3. Okay. on this line all x are 3. On this line all x are 3. Okay, once again, we will, what is the statement that, what is the aim that we have? We have the aim that we will examine the continuity of f of x. Okay, so let me now plot the function f of x. Let me now plot the function f of x. So suppose you have a function f of x, which when you plot, it goes like this. Suppose it goes like this. Okay, this is your function f of x. You plot it and you got it this way. This is y equal to f of x. You plotted. Okay. Now what you see here is, you see that when x is 3, you see here that when x is 3, the function is having the value which is this. See, the value of the function at x equals to 3 is this number. You check this. So this is the value of the function when x is 3. When x is 3, the function has this value. Suppose this value is 1. So this is say 1, this is 2, and this is say this is 2.2. Got it? So when x is 3, the function has value 2.2. So here I can write the coordinate of this point. The coordinate of this point I can write 3 comma. I can write here 3 comma 2.2. Okay. The value of the function when x is 3 is this. Further, what I notice is when I'm moving on the function, check, this is the function. Okay. See what I'm doing. I'm moving on the function. Okay. This way. From left to right. I'm moving on the function from left to right. Now, as I'm moving on the function from left to right, what is happening? The value of x is approaching 3. You can check. What is happening? The value of x is approaching 3. See, as I'm moving on the function from left to right, what is happening? The value of the x is approaching 3. Definitely, see, when you go this way, at every point, what would happen? The value of x will go close to 3. For all these points, if I write the coordinate of all these points, every point will have its x coordinate approaching 3 because you are moving from left to right. Okay, the value of x is approaching 3. And when x is approaching 3, what did you notice? You notice that when x is approaching 3, as you move from left to right, y is approaching 2.2. Okay, y will approach 2.2. If you write the coordinate of all these points, you will notice that for all these points, x value is approaching 3 from left. X value is approaching 3 from left. And for all these x, y value is approaching 2.2. Now, on the same function, if you move from right to left, that is, now this time you move from right to left. Here you went from left to right. Now you go from right to left in such a way that the x coordinate is approaching once again 3. Okay, so as you know, if I for all these points, if I draw the perpendicular, what you notice, you can check. See, as you are moving on the graph from right to left, you should understand, as you are moving on the function from right to left, The value of x, you can check here the value of x. The value of x you can check. This is 7 point something, this is 6 point something, this is 6 point something, this is 6, then this is 5, then this is 4, then this is 3 point something, 3.1, 3.01, 3.001. What do you notice? You notice that the value of x, when you move from right to left on the graph, on the function, the value of x is approaching, the value of x is approaching 3. Once again, see, this time from here, it is approaching 3 from here. And when the value of x is approaching 3 from the right, what is happening to value of y? So you will notice that y is once again approaching 2.2. Y value is approaching 2.2, which happens to be the value of the function when x is equal to 3. So from this side you wrote when x is approaching 3 from left, see the value of x is approaching 3 from left and y is approaching 2.2. Here you notice that value of x is approaching 3 from right. So you will write here when x tends to 3 positive, y still approaches 2.2. So what you notice here? You notice here that when x is approaching 3 from left, y, the function f of x, is approaching 2.2. So from this you will write, see for this what you write? You will write here limit f of x, when x tends to 3 negative, that is left hand limit at 3. Limit f of x, limit of the function when x is approaching 3 from left is equal to 2.2. The function is approaching which number? When x is approaching 3 from left, the function of x is approaching 2.2. And here you would write for the right hand side, you will write limit f of x when x tends to 3 positive is also 2.2. Okay. Now when you have these two, that is the left hand limit at 3 and the right hand limit at 3 are equal, what would you write next? This will make you write, therefore, limit, see the left hand limit and right hand limit at x tends to 3, as at x tends to 3 are equal. So this means limit f of x at x as x tends to 3 exist. You know, if the left hand limit and right hand limit at 3 are equal, then the limit at 3 exists. Had these two been not equal, if the left hand limit and the right hand limit would not have been equal, we would have said the limit at x tends to 3 does not exist. So here limit exists, and what you have, the value of the limit you have is 2.2. The value of the limit you have is 2.2. And what is f of 3? What is value of f of 3? If I ask you the value of f of 3, it means I'm asking you what is the function value when x is equal to 3. So see, when x is equal to 3, the function value is 2.2. The function value is 2.2. So from these two, what I understand that limit f of x, I understand that limit f of x when x tends to 3 and f of 3, they are equal. That is, the number which f of x approaches when x is approaching 3 is equal to the number which f of x assumes when x is equal to 3. They are equal. And when they are equal, we say the function is continuous at x equals to 3. What we will say now? See, this is the definition of continuity. Here what you wrote limit f of x, x tends to 3, limit f of x, x tends to 3 equals to f of 3. So now you are in a position to write, therefore, You will write f of x is continuous. F of x is continuous at x equals to 3. So here we wrote f of x is continuous at x equals to 3. X equals to 3, and we wrote the function f of x. You see this pink graph, the curve? We said the function f of x is continuous at x equals to 3. In simpler words, in layman's language, a function being continuous at x equals to 3 would simply mean that if I'm tracing the curve, if I am tracing the curve from left to right or from right to left, and when I come to number x equals to 3, I will not have to lift my pen. See, there is no break here. You see this? It's a continuous curve so far as x equals to 3 is concerned. At x equals to 3, you see no break in the function. When you move on the curve from left to right and you go past 3, okay, or you move from right to left and you go past 3, you will notice that at this number, the function is continuous. You don't have to lift your pen. You see, you don't have to lift your pen, pencil, whatever. It is a smooth curve, which is a continuous curve from at x equals to 3. See, the function is continuous at x equals to 3. The function is continuous at x equals to 3. But the same thing when you have to speak mathematically, how would you say? For mathematically, you will say the function is continuous at x equals to 3 because limit f of x when x tends to 3 is equal to f of 3. Okay, now let's go to the next diagram. The next diagram will give you more clear picture. See students, as I told you, you have to have patience. Okay, so be patient. Slowly and slowly, the things will unfold and you will get a big clear picture of continuity of a function. Okay, it is only the first lecture. We are still at the beginning of the topic. So now see here. I have f of x. This time I have another function, say the function g of x. Okay, so here I write, here I have, suppose the question here is, there is a function g of x and we have to examine the continuity of function g of x at x equals to 3. So the point of discussion, point of examination is still the same, x equals to 3, but the function this time is g of x. Now I plot the function once again, and this time when I plot the function, see how the function is. The function is this way. Check. The function is this is the, now from here, it might be going to some, see, it may go to infinity this way. We are not concerned, and here also. Right now, my point of concern is only 3. So what I notice here that function g of x, this is y equal to g of x. What's the function? The function is y equal to g of x. And there is one point here. See, this is how the function is appearing to be. Now look at this function. What is happening in this function? On the function y equal to g of x, when I move from left to right, on the function, that is, I am approaching the number 3 on x-axis. See, if you draw perpendiculars from each point on the x-axis, if you draw perpendicular from each points on the x-axis, you will notice that the value of x is increasing and the value of x is approaching 3. See, you will notice that value of x is increasing and the value of x is approaching what? It is approaching 3, right? See, as you move on the function this way, the value of x, for every point, the x value would increase. And what is it? X approaching? X is approaching number 3. X is approaching number 3. Yes. And when x is approaching number 3, see what is g of x approaching? For that, from each point, now you draw a perpendicular on y-axis. Draw a perpendicular on y-axis. You will know, see. As you move from left to right on the curve, you notice that y value is coming close to, you can check, y value is coming close to number 1. See, as the x values are coming close to, as the x values are coming close to 3, the y value is coming close to where? See, this point, try understanding. This point here has y value equal to 1. This point here has y value equal to 1. You understand? So, what I will write here? I will write here, when x tends to 3 from left, y or g of x, whatever you write, y tends to 1. What is y tending to? The more you go close to 3, okay, closer you will reach to 1. As you move on approaching 3, the function value will keep on coming close to 1. See, it will never be below 1. No, it will just keep on coming close to 1, 1, 1. On the other hand, if you check this out, if I move from right to left on the curve, approaching number 3, this time, once again, what is happening? We are coming close to number 3. You check this line, every number on the line is 3. So as x is approaching 3, once again, what is happening? See, when you move from right to left, there is a drop in the x value. X value is somewhere here, you know, the x value will be 5. Somewhere here, it will be 4.5, 4, 3.5, and so on. So you notice a drop in x value, but that drop in the x value is taking it only closer to number 3. And as x is approaching 3, you once again understand that y value is approaching 1. See, there is a rise in y value, and that rise in y value is taking it closer to 1. So you will write here, when x is approaching 3 from right, that is from the higher side, what you will write? You will write when x is approaching 3 from right, that is x tends to 3 positive, y is approaching 1. So once again, what would you see? This part here, you write, this is your left hand limit. You will write limit g of x when x tends to 3 is 1. When x tends to 3 negative is 1. And here you would write limit g of x when x tends to 3 positive is also 1. So in both the cases, you know, the left hand, when x is approaching 3 from left, the function is approaching value 1. When x is approaching 3 from right, the function is approaching value 1. From either side, the function is approaching 1. So the left hand limit and the right hand limit both are equal. And you know, when the left hand limit, right hand limit are equal, what do you write? You write here limit g of x tends to 3 exist. What do you write? The limit value exists. Okay, the limit of the function at x tends to 3 exists, and you write limit g of x tends to 3 is equal to 1. It is equal to 1. So the limit here is equal to 1. I want you all to make a note of this step in this diagram and the similar step in the earlier diagram. See, in the earlier example also, the limit of the function existed. It did exist. And what the limit was? Limit was 2.2. The limit value was 2.2. Limit at 3 exists because from either side, the function is approaching the same number on y-axis, and here also. But there is, after this, there is a big difference in the two examples. That is, in this example and the earlier example. Students, if I ask you the value of function g of x when x equals to 3, check this out. If I ask you what is g of x equal to, what is g of x equal to? This is a question mark. If I ask you what is g of x equal to when x equals to 3. Remember students, in the earlier two cases which I just talked about, I explained you, in earlier those two cases, x was approaching 3. X was approaching 3. In one case from the left, here from the right. But now what I'm talking about is when x is equal to 3. Try understanding. When x is 3. When x is 3. X is equal to 3. In the earlier two cases, nowhere x was equal to 3. Remember, in earlier two cases, nowhere x was equal to 3. Nowhere. In this, x is approaching 3 from left. In this, x is approaching 3 from right. And it would keep doing so. It would keep doing so for ages. But now when I say x equal to 3, I actually mean the point where x is 3. So when x is 3, what is function value? See, the function value is given to be 4. What is it given? It is given to be 4. So please let me write. See, here is the point defined. When x is 3, the function value is 4. You see this? The function value is 4. That is 3 comma 4. 3 comma 4. Please understand. It is 3 comma 4. So I will write here g of, when x is 3, g of x is 4. My answer is, okay students, now I will write my answer. I will write my answer when x equals to 3, g of x is equal to 4. What does that mean? When x is 3, g of x is 4. It means g of 3 is equal to 4. G of 3 equals to 4. Now from these two, you can check. Okay, I want you all to check this. In this, what is happening? Here, I want you all to be very, very, very attentive. Okay, we are coming to a very important point. See, in this, from 1 and 2, what we can conclude? Limit g of x when x tends to 3 is not equal to g of 3. You check this? They are not equal. When x is approaching 3 from either side, the function is approaching 1. The function is approaching 1. But when x is equal to 3, the function is not 1. And because of which, what is happening? You see a hole here. Students, please, okay, look at this. You see a hole here. You see a hole here. And because of this hole, there is a break in the function. There is a break in the function. There is a break in the function. There is a discontinuity in the function. And why is this discontinuity happening? It is because this point is not here. This point is not here. If this point had been, this point you see here, 3 comma 4, if this point had been here, what would it have done? What would it have done? It would have filled the gap. You see the gap? It would have filled the gap. This point would have filled the gap. But unfortunately, it is not that way. And because of which there is a break in the function. And since there is a break in the function, what you will say? You will say that the function g of x is discontinuous at x equals to 3. Break in the function. Break in the function. Okay, at x equals to 3. At x equals to 3. What would you say here? You will say the function g of x, you will say here, the function g of x, the function g of x is discontinuous. It is discontinuous at x equals to 3. Okay, why it is discontinuous? Because look at the left hand side. The limit of g of x when x tends to 3 is not equal to value of g of x when x is equal to 3. Okay, what is left hand side? It is the limit of g of x when x tends to 3. That is, it is the number which g of x is approaching when x is approaching 3. So what you notice? You notice that when x is approaching 3 from either sides, the function g of x is approaching 1. The function g of x is approaching 1. Okay, from either side, it is coming close to number 1. But when x is equal to 3, it is not 1. What it is? It is 4. It is 4. And because of which the function is discontinuous at x equals to 3. Okay. Now see here in both the examples, I took x value 3, x equal to 3, just for the sake of making it understandable. You could have taken any number, 2, 3, whatever real number. Okay. I hope you followed it. Just go through this once again. So in other words, what I can say for this particular example is that if I'm moving on the curve from left to right, and when I go past this number 3, I have to lift my pen. You see this? I have to lift my pen and then come here, or I have to jump. See, I have to jump. Why I need to jump? Because here I notice there is a break in the curve. There is a break in the curve. So if I'm moving my pencil, if I'm moving my pencil or my pen on the curve from left to right, okay, and I go past this number 3, see, I have to pick this up. I have to pick the pen up to come to this side. Or the same thing, if I'm moving from right to left, I have to lift my pen and then go on this side. You understand? So the function has a break at x equals to, the function has a break at x equals to 3. So you understood what is meaning of continuity of a function at a point and discontinuity of a function at a point. Now I will give you one more example. As such, there are plenty of things which will keep coming and that will make you smart in the topic. So with the same aim, let's go for the next example. So once again, I have here. So in this example, I write here, examine the continuity, of function h of x. This time I'm taking another function h of x at x equals to 3. See, deliberately I'm taking the point in all the examples as 3. So this time what I notice is the function which I have is, it happens to be this way. Okay, so here it might go to infinity. Let us not worry about that. So we are more concerned about 3 because we have to examine the continuity of the function h of x at x equals to 3 at. So I notice that when x is approaching 3, that is, if I move on the function and I move on the function from left to right such that I'm coming close to x value 3. I'm coming close to x value 3. See, when you are moving on the function, so the projection, if you see the projection of the points as you move on the function from left to right, you notice that the x value is also approaching, the x value is approaching number 3. X value is approaching number 3. So when x is approaching 3, you will notice that the function is approaching 2 on y-axis. See, the function value is always taken on y-axis. So what is the function value approaching? When x is approaching 3, the function value is approaching 2. The function value is approaching 2 here. You see this? The function value is approaching 2. So as x tends to 3, what I would write here? I would write x tends to 3 from left, y tends to 2. Y tends to 2. And in the language of limits, I will write, see, if I keep taking x value closer to 3, the function would keep on dropping and it would approach number 2. Okay, so here I will write limit of g of, I'm sorry, it's not g of x, it's h of x. Limit of h of x when x tends to 3 from left, it is equal to, the limit is equal to 2. The limiting value is 2. Okay. What is the limit of the function when x is approaching 3 from left? 2. And see, the other branch of the function is this way. The other branch of the function is this way. Okay. So when x is approaching 3 from right, see, if I move on the graph of the function, that is the curve h of x, this is curve y equal to h of x, y equal to h of x. Okay, if I move on the curve from right to left, and as I proceed ahead from right to left, okay, I notice that function x value, on the function the x value is approaching number 3. The function x value is approaching 3. And when x is approaching 3, look at the function. Function is approaching which number? Function is approaching number 5. See, it is approaching number 5. So what would we write here? We would write here, as x tends to 3 from right, we will write here x tends to 3 from right, x tends to 3 positive, x tends to 3 positive, y tends to 5. And here in the language limits, in the limit language, you will write limit of h of x when x tends to 3 positive equals to 5. Now what we have, the left hand limit and the right hand limit, they are not equal. See, for the first time, the left hand limit and the right hand limit, they are not equal. So here we will write limit h of x when x tends to 3 negative is not equal to limit h of x when x tends to 3 positive. Therefore, limit h of x tends to 3 does not exist. What would we write? We would write that limit does not exist. Remember, the limit extends to 3 h of x does not exist. Okay. You cannot write that limit h of x extends to 3 is 2 or it is 5. You cannot give two values to limit. Yes, you can definitely say that left hand limit of h of x when extends to 3 negative is 2. You can say the right hand limit of h of x when extends to 3 positive is 5. But when it comes to only the limit of h of x as extends to 3, okay, since the left hand limit at 3 and right hand limit at 3 are not equal, you would say that limit at 3, limit of h of x when x tends to 3 does not exist. This is what you would say. Okay, so limit does not exist. And remember students, when the limit does not exist, there is no question of continuity at x equals to 3. You can check here, there is a jump. There is a jump in the function. You check here, there is a jump in the function. Okay, here there was a discontinuity, but this discontinuity was due to a gap. It's a discontinuity because of a gap. Why? Because the limit existed, only the function value at x equals to 3 wasn't equal to that limit value. Okay, but here what is happening? See, in this case, the left hand limit and the right hand limit, they were equal. You can check from both the branches. When x tends to 3, see, the function from the left and function from the right, they are coming to same height. That is, number one, they were coming to left hand limit and right hand limit were equal. But in this case, what is happening? In this case, we notice that left hand limit is 2 and the right hand limit is 5. Okay, the functions are from either side of 3, the functions are not approaching the same number, and you would say that limit does not exist at x equals to 3 and the function is discontinuous. You will write, therefore, function h of x is discontinuous at x equals to 3. Now remember students, if you are thinking that like the earlier two examples, why aren't we defining the function value when x is 3? Why are we not defining the function value when x is equal to 3? See, once the limit does not exist, the value of the function at x equals to 3 is insignificant, because no matter what it would be, the function will always remain discontinuous. Because even if suppose I write when x is 3, the function value is 2. So what would happen? It would give us a point here that would only take the graph till 2. That would only stretch the graph till this number 2. But still it would be discontinuous. You can check, it is a jump. No matter what you do, you cannot fill this jump. It is impossible to fill this jump. Okay, because at x equals to 3, you are going to just have a point. That point can be anywhere. When x is 3, suppose the function value is 3, so you will get a point here, but still it may not be sufficient to make the function continuous. Okay, so far we have discussed three cases. In the first case, we had the function continuous at x equals to 3. That 3 could be any number. So in the first case, the function was continuous at x equals to 3. In the second case, the function was not continuous at x equals to 3. It was discontinuous. But this discontinuity was a discontinuity due to a gap. It's a gap discontinuity. You can say it's a gap discontinuity. And remember, when there is a gap discontinuity, the limit of the function on either side exists. It is only the value of the function when x is equal to the point is not same. So you notice that left hand limit of g of x when x tends to 3 and the right hand limit of g of x when x tends to 3 were equal, but it was the value of g of x when x is equal to 3 which was not equal to the limit value. So this is gap discontinuity. It is gap discontinuity. And then the third one was the function was discontinuous, and this kind of discontinuity is known as jump discontinuity. Jump discontinuity. And remember, when there is a jump discontinuity, the limit of the function does not exist at the point of discussion. Okay. And what about the value of the function when x is equal to the point of discussion? Like here, the if somebody asks you what is g of x, sorry, what is h of x value when x is equal to 3? Okay, if somebody asks you what is h of x equal to when x equals to 3, so frankly speaking, this is insignificant here. No matter what value you write for h of x when x is equal to 3, the function would always remain discontinuous. But still, there are few cases which I would complete in order to have the clear concept. So what are those few cases? I will write here. Suppose if it happens so that h of x, if it happens so that h of x value, okay, so here I write case 1, and in case 1 I write h of x is equal to 2 when x equals to 3. H of x is equal to 2 when x equals to 3. What does that mean? When x is equal to 3, you know x equals to 3 means you are at this point. Remember, you can only be at this point, for x equal to 3. Otherwise you cannot come at this point. You can come to this point only when x is equal to 3. So when x is equal to 3, the function value I wrote, h of x is 2. So what is, when x is 3, what is h of x value? It is 2. So here you have the point. See, it is 2. Now you come to 2 here, or else, see, it wasn't at 2. You can check this. You can closely observe this. You can check here. The function is coming close to number 2. It is not at 2. It is not at 2. Okay. So when you say the function is equal to 2, when you say the function value is equal to 2, what does that mean? It simply means that you have a point here at 2 also. You have, when x is 3, you have the function value as 2. Okay, so what would we write here? We would write here, therefore, h of 3, you write here, h of 3 is equal to 2. H of 3 equals to 2. And remember, students, when such a thing happens, that is left hand limit of the function is 2 and h of the value of the function is also 2, you would say the function is continuous from the left. So here what I will write, I will write here limit h of x x tends to 3 negative is equal to h of 3. You see this? It is equal to h of 3. Hence, hence, hence the function is, hence h of x is continuous, continuous from left, from left of x equals to 3. It is continuous from left of x equals to 3. Please understand. It is continuous from left of x equals to 3. Okay. The function is not, please do not misunderstand. I am not writing the function is continuous at x equals to 3. That can never happen. What I am writing the function is continuous from the left of x equals to 3. From the left of x equals to 3. And suppose this point, and suppose this point which I drew here, it had been, if it wasn't here and this were, if it wasn't here and it was somewhere, that point wasn't here, that is when x is 3, the function value, if it was say 5, if the function value was 5, in that case what we would have said, we would have said that that is case 2, that is case 2, and in case 2 this is case 2, and in case 2 suppose h of x equals to 5 when x equals to, when x equals to 3, when x equals to 3, when x equals to 3, that is h of 3 equals to 5. In that case what would you see? You will see that limit h of x when x tends to 3 from right is equal to, it is equal to h of 3. It is equal to h of 3. So what would you write? You will write hence the function h of x is continuous. Hence the function h of x, I'm sorry, we have a habit of writing f of x. So hence the function h of x is continuous. It is continuous from right of x equals to 3. Remember students, both the cases cannot happen in one example. In any example, it would either be case 2 or case 1. You cannot have a function where it is continuous from left as well as from right. That is not possible. Why? Because if the function value, if the function value at 3 is 2, then it cannot be 5 at 2. The function will have only one value at x equals to 3. That you need to understand, that when x is equal to 3, the function will either have value here or it will have value here. It cannot have value at both the places. How can the function be equal to 2 as well as equal to 5 for x equals to 3? If this happens, then that is not a function, because then it goes against the definition of function. The function should always have a unique value for any given x number. Okay, so either the function will be continuous from the left or it will be continuous from the right. I have explained this to you in much detail. So now we are in a position to write the definition of continuity of a function f of x at x equals to a. So here there is a, I write the question, define continuity of f of x at x equals to a. So remember students, what are we going to do in this topic? We are going to check, we are going to examine, we are going to test the continuity of a function at a point x equals to a. This is what is our aim going to be. We are going to discuss the continuity of f of x at a point x equals to a. What does that mean? It means we want to check, we want to examine if the function is continuous at this point, or the function f of x has a break at this point, or a function f of x is having a jump at this point. Okay, whether it's a smooth curve at that point, or it has a break at that point, or it is a jump at that point. That is what we want to check in this topic. Okay, so we have a question here, define. So I will write the definition. Okay, so here I write definition of continuity of f of x at x equals to a. So I write a function f of x, is said to be continuous at x equals to a if a function f of x is said to be continuous at x equals to a if what, if this happens. See students, this box has got left hand side and right hand side. If this left hand side is equal to right hand side, then we will say the function is continuous at x equals to a. I repeat once again. So what are we writing in the definition? What did we write? We wrote a function f of x is said to be continuous at point x equals to a. A function f of x, I would say it is continuous at x equals to a point x equals to a. If this happens, what is it? I will have one left hand side. That left hand side needs to be equal to the right hand side. So if the left hand side and right hand side are equal, then I would say the function is continuous at x equals to a. Now the question is, what do we have on the left hand side and on the right hand side? Okay, so let me write the left hand side. Students, what is the point of discussion? Remember students, the most important here is this point of discussion. Okay, so what is the point of discussion? Where do we want the function to be continuous? It is at x equals to a. Okay, so see, the left hand side will be limit of the function when x tends to a. Limit of the function when x tends to a. Okay, why a? Because the point of discussion is a. And what is the right hand side? The right hand side is f of a. Now you understand meaning of these two sides. What is this? It is the number which function is approaching when x is approaching a. What is limit f of x tends to a means? Limit f of x tends to a means when x is approaching a, the function is approaching some number, and that number you give by this. And what does this mean? It means the function value when x is equal to a. It is very important that on the left hand side you don't take x as a. X is not equal to a here. X is only approaching a. You saw in the examples. See, x was approaching 3. See, x was approaching 3. See, x was approaching 3. X was not equal to 3. That is the limit. And then you have the function value when x is equal to a. The next step was what? X is equal to 3. When x is equal to 3, what is the function value? So in the left hand side, when you calculate for the left hand side, what do you actually calculate? You find the limit value of the function. That is, what is the number the function is approaching when x is approaching a. And on the right, What is the value of the function when x is equal to a? If these two happens to be equal to each other, you will say the function is continuous at x equals to a. You say the function is continuous at x equals to a. Okay. So for this lecture, this much is enough. We will, in the next lecture, we will start solving problems. So before I start with the problems in the next lecture, see towards the end, I will give you some for example, see here, a function, let me write few examples. A function f of x is continuous at x equals to 5 if what, if limit f of x tends to 5, if limit f of x tends to 5 equals to f of 5. You see this? Okay, one more example I will write. See, second I will write a function g of x, a function g of x continuous is continuous at x equals to pi by 2 if what, you will first calculate on the left hand side the limit. So limit g of x, what is the point? Pi by 2. So x tends to pi by 2 is equal to g of pi by 2. That is the value of the function when x is pi by 2. Okay. One more example I will take here. Let me write one more example. Okay. First I make the screen complete black. Now see the third one I write a function h of x is continuous at x equals to minus 2 if what, see on the left you have limit value, limit h of x when x tends to negative 2, limit h of x when x tends to negative 2 equals to h of negative 2. Okay, I hope you have followed this, practice this definition well, and watch this video again. In the next lecture, we will start solving problems. Thank you.